One of the laboratory skills that you really must master at this level of chemistry is how to prepare a solution. So let's say we have some copper 2 sulfate and we want to make a solution out of it. Well, first of all, we have to know the concentration of our solution. We have to know what volume we want to make in order to work backwards, and we'll do that in a calculation soon, to calculate the number of grams necessary for the copper 2 sulfate in the solution. So we'll weigh out a certain amount of copper 2 sulfate using a scupula, of course, to be able to transfer it perhaps into a beaker right away that has been tiered on an electronic scale. So once you've got your solid in there, you want to dissolve it into some water. So you'll pour some water in, stir it up with a stirring rod. Let's say you want to make a 100 milliliter solution. Well, don't fill it up to the 100 milliliter mark on the beaker, because beakers are a very inaccurate way of determining volume. Hey, by the way, if you had some solid on here, on this stirring rod, you would then lose it as you put it down on a lab bench. So you would never want to do that. Watch this. So what you want to do is make sure that this solution gets prepared into a piece of glassware that will accurately give you 100 milliliters. So what's that? Well, how about a graduated cylinder? Nope, believe it or not accurate enough. Well, how about one of them little graduated cylinders, and we'll just do it quite a few times? No, that's even worse. Alright, what you need to use is this right here. That's called a volumetric flask, a 100 milliliter volumetric flask with only one line of measurement on it. That little line that you see there, carved around here, when the bottom of the meniscus of a solution touches the line here to within 2 decimal places, you've got yourself 100 milliliters. That's what you make a solution in. Now, what you want to do is then get a funnel and be able to transfer the solution that you're starting to prepare in here through the funnel into the flask. Make sure that you get what we call a wash bottle or some beaker full of water here, and rinse off the stirring rod and the beaker. Put that into the volumetric flask. Rinse it off again, because if you wouldn't lick it, it's not clean. That's my rule. Then you're going to take a little wash bottle to rinse out that funnel, and every time you rinse there, you did not pass that meniscus line, because if you did, you've got more than 100 milliliter solution. So maybe the water level is up to here. What you want to do then is bring it up to just below the line, and then get some water in an eyedropper, plink, 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 to finish the job. When the bottom of the meniscus of the solution touches that line, you've got yourself 100 milliliters, as precisely as you can determine it in a lab. You saw the pipette in the last demonstration. Well, what's that pipette doing? It's helping to perform a dilution. A dilution where we're taking a known concentration initially and turning it into a different concentration by adding more solvent. Okay, so here's a good question. 200 milliliters of 0.2 mole per liter. Now, by the way, sometimes you'll see moles per liter written as big M beside the number. Don't get freaked out. It doesn't mean anything other than concentration, moles per liter. Sometimes I do that at university. 200 milliliters of 0.2 mole per liter solution, it's diluted to 500 milliliters, so its concentration is going to go down. What's the new concentration? Well, just think of it this way. You're going to have to pour in more solvent to bring it up to 500 milliliters from 200 in order to get a new concentration. The concentration is going to go down. But you know, the moles never changes. So the moles stays the same before dilution and after dilution. Concentration times volume equals moles. So the moles before equals the moles after, or CIVI, concentration initially, volume initially, equals concentration finally times volume finally. I like the formula here because it's more than 3 terms to put in. So what do? We plug numbers into the formula and we find out what we're looking for. Let's take a look. What are we looking for? The new concentration. That's the final concentration. And so we want to actually do the algebra to solve for CF. So what do? Divide each side by VF to get VF to cancel here. So our formula is final concentration equals CIVI over VF. Now, we plug the numbers in, we find the final concentration. Numbers substituted into the formula. There's your initial concentration and your initial volume. There's your final concentration. And by the way, since milliliters is in the numerator and denominator, I don't have to convert to liters. Those mils will cancel and leave with moles per liter. And as a matter of fact, the answer is 0.080 to 2 significant digits because of the 2 there. That's the new concentration. You look at that and you say, oh, that sounds right because the concentration has to go down from 0.2, and it does.